The relation on the left-hand side, we want to see if that is a function. So when we look at this mapping diagram, all of the domains are getting mapped to a range, but none of the domains are repeating. So that is a function. Now the inverse of that, okay, where the domain and the range are switched, when we look at that, the new domain now has multiple arrows coming from the same number. So 1 is getting mapped to 1.2 and to 1.4. So since the x's there are repeating, the domains are repeating, is this a function? No. Okay, so the main idea here is that when you have an inverse of a function, that the domain becomes the new range. And the range becomes the domain. So what's happening is that the x's and the y's are switching in these relations. So all of the domains of the original becomes the range of the inverse. And the range of the original becomes the domain of the inverse. So here we want to find the inverse of each relation. So all we're going to do is literally flip the points. So for the inverse, if I make an XY chart here, instead of 1, 0, I have 0, 1. Instead of 2, 1, I have 1, 2. Instead of 3, 0, I have 0, 3. And instead of 4, 2, I have 2, 4. So I could graph these and see if they're functions or not. But if we look at the original, we want to look at the x values. Are any of the x's repeating? Okay, so none of the x's are repeating. So the original is a function. So that is a function. The inverse of that, if we look at the inverse here, we see that the x's are repeating. There's 2 zeros. So this is not a function. And if we graph these points, we would see that if we did the vertical line test on the inverse, that it would cross through the same x value twice. Okay, so if we look at the next one, again, we want to write the inverse. So all we're doing again is switching the x's and the y's. So instead of 0, 0, we have 0, 0. Instead of 1, 1, we have 1, 1. Instead of 2, 4, we have 4, 2. And instead of 3, 9, we have 9, 3. So if we look at the original, okay, none of the x's are repeating, so that is a function. And then if we look at the inverse, none of the x's are repeating, so that is also a function. To find the inverse of a function, we want to switch the x and y values and then solve for y. And then we want to see if the inverse is also a function. So this original problem, we have a linear. Okay, so the linear is a function. If I switch the x's and the y's, I have x equals 4 minus 3y. So now what I'm doing is I'm solving for y. So I'm going to bring my 4 to the other side. So I'm going to subtract 4. So I'm just going to flip the way this is written. So I'm going to say negative 3y equals x minus 4. Okay, so all I did right now was subtracted 4 on the other side. And then if I divide each side by negative 3, I get y equals negative 1/3 x plus 4/3. So this is my inverse. And my inverse is also a linear. So yes, this is a function. Okay, in the second one, I'm going to flip my x's and my y's. So I have 3 minus 2y squared minus 1. So I'm going to add the 1 to the other side to get the 3 minus 2y squared by itself. And I'm just going to flip this at some point. So I'm going to do 3 minus 2y squared. So now I want to take the square root of each side, because I want to get rid of that square. So I'm just going to flip the way this is written. So I'm just going to put the 3 minus 2y on the other side, just because we're used to seeing y equals on the left. So 3 minus 2y equals, now when I take the square root of x plus 1, I get plus or minus the square root of x plus 1. So now I want to subtract 3 on both sides. So just be careful. That 3 that you're subtracting, you can't actually subtract it with that 1 since the 1 is under the radical. So we're going to have negative 2y equals, and then the last step is divide by negative 2. So I get y equals 3/2 plus or minus 1/2 radical x plus 1. So I'm just breaking it into each piece here. Okay, so here's my inverse. And is this a function? Well, the key here is this plus or minus. If you see a plus or minus, it's not going to be a function. So no, that is not a function because of that plus or minus. Okay, so we're going to do the last one, but I'm going to do it on another page so I have more space. So it was y equals 3x plus 1 over 2x minus 3. So what we're doing here again is switching the x's and the y's. So I'm going to get x equals 3y plus 1 over 2y minus 3. Now this might seem tricky because you have y's on the top and the bottom. So we just want to get rid of our fraction. So first we're going to multiply both sides by 2y minus 3. And then when we do that, those are going to cancel out. And I'm actually going to distribute the x. So this is going to give me 2xy minus 3x equals 3y plus 1. So now what we want to do is we want to get all of our y's on the same side. So I'm going to subtract the 3y to bring it over here. And I'm going to add the 3x. So these are going to cancel out, those are going to cancel out. So on the left-hand side, what I have now is 2xy minus 3y. On the right-hand side, I have 3x plus 1. So that left-hand side, I have 2 y's there. So what I need to do is factor that out. So I'm going to take the y out. So I have 2x minus 3 equals 3x plus 1. And now I can divide by 2x minus 3. So y equals 3x plus 1 over 2x minus 3. And this is a rational function. So since it's a rational function, I know that yes, this is a function. Okay, so the key is that plus or minus. If you see a plus or minus, it's not a function. Pretty much everything else is going to be a function. Okay, so again, we're going to flip the x's and the y's. So 3y plus 1. And then we want to get the y by itself, so I'm going to subtract the 1. I'm just going to change the order. So 3y equals x minus 1. And then divide by 3. So y equals 1/3 x minus 1/3. And this is a linear function. So yes, the inverse is a function. Okay, next one, again, change the x's and the y's. I'm just going to change the order. So I'm going to subtract the 4. And then I have to take the square root. So y equals plus or minus the square root of x minus 4. So here's my inverse. And because I have that plus or minus, this is not a function. Okay, and the last one, again, change the x and the y. Then we want to get rid of that square, so we're going to take the square root. Just going to change the order, so 2 minus y equals plus or minus radical x. And then I'm going to subtract my 2. So negative y equals negative 2 plus or minus radical x. And divide by a negative 1. So we just get 2 plus or minus radical x. So this is my inverse. And again, because I have that plus or minus, this inverse is not a function.